PSLE 2016 Challenging Questions, Science. Let's look at the first question. The diagrams below show two types of moths found in Town A. The trunks of the trees in Town A are light-colored. Which moth would survive better in Town A? Give a reason for your answer. Consider the visibility of the black and white moths against the light-colored tree trunk. Which do you think will be more easily spotted? For the white moth, its structural adaptation matches that of the light-colored tree trunk. Let's look at the answer. White moth. The color of the tree trunk is similar to the color of the white moths. Thus, the white moths can camouflage with the tree trunks, reducing the chance of them being spotted easily by their predators. Let's look at part B of the question. After a few years, there was air pollution in Town A that caused the tree trunks to appear darker. Describe how the darkening of the tree trunks affected the population of both types of moth. Explain why. We have to consider the change in population sizes of the moths as a result of the tree trunk becoming darker. Populations will either increase, decrease, or remain constant. Let's look at the answer. The population of the white moths will decrease, while the population of the black moths will increase. The black moths will be less visible against the darker tree trunks than the white moths. A comparison has to be made between the black and white moths. The phrase "less visible" shows this. Let's look at the next question. The diagram below shows animal M growing on the shell of a crab. Animal M is poisonous and stings other animals. How is it an advantage for the crab when animal M grows on its shell? Both organisms benefit from this relationship. It is known as symbiosis. Let's look at the answer. Animal M can sting the crab's predators when threatened, reducing the chance of the crab being eaten by its predators. Let's look at part B of the question. How is it an advantage for animal M to be growing on the crab's shell instead of growing on a rock? A comparison must be shown between animal M growing on the crab and on a rock. Let's look at two possible answers. The crab moves around, but the rock is stationary. So, animal M will be carried to more places, increasing its chances of obtaining food. Animal M gets to eat the remains of food that the crab leaves behind. Movement to other locations enables both the crab and animal M to look for food more easily. Let's look at the next question. There were two islands, Q and R, which were near each other. Plants and animals were found on island Q only. After some time, plants were found to be growing on island R. Explain how plants started to grow on island R. We are considering methods of dispersal here. The methods are wind, water, animals, and splitting. However, dispersal by splitting is not likely due to the distance between the islands. The other three methods are possible. Let's look at two possible answers. The fruits and seeds of the plants on island Q were dispersed by wind or water to island R. These seeds germinated and grew into plants. The fruits of the plants on island Q were eaten by animals, and the undigested seeds were released with their waste on island R when the animals visited the island. The seeds germinated and grew into plants. Let's look at part B of the question. Explain why animals appeared on island R after the plants had started growing. Animals need air, water, and food to survive. Let's look at the answer. Plants are food producers. Animals moved to island R to feed on the plants. Let's look at part C of the question. Explain why the population size of animals on island Q remained constant while that on island R increased over time. For island Q, the ecosystem was balanced. Although there was a migration of animals to island R, the higher rates of animal reproduction due to less competition for food will ensure a stable animal population. For island R, the animal population is likely to increase due to the increasing population of food producers. Note that graphs are not needed in the answer. Let's look at the answer. There was a balance of food producers and consumers in the community on island Q to keep the population stable. There was a greater amount of food available for the animals on island R. Let's look at the next question. Sarah conducted an experiment using setups A and B shown below. Both beakers contained the same volume of hot water at the same temperature. After a period of time, Sarah observed that the temperature of the water in setup B was higher than that in setup A. What could Sarah conclude from her observation? Let's examine the setups again. Note that there is a layer of air trapped between the two containers in setup B. This is the difference between both setups. Which property of air is being demonstrated here? Let's look at the answer. The layer of air in setup B is a poor conductor of heat. So, the air slowed down the heat loss from the hot water to the cooler surrounding air. A common misconception is to state that the hot water gained coldness from the colder surrounding air. This is incorrect because only heat is lost or gained, not coldness. Let's look at part B of the question. The polar bear lives in a very cold environment. The diagram of a polar bear's fur is shown below. Based on your conclusion in the above experiment, how does the thick fur help a polar bear keep warm in the cold environment? The answer in part B is based on the same concept as part A. The context has been changed. The thick fur of the bear is a structural adaptation. The diagram shows air being trapped in the fur. Which property of air can be applied here? Let's look at the answer. The layer of air trapped in the thick fur is a poor conductor of heat. Thus, the air slows down the rate of heat loss from the polar bear to the colder surroundings. Let's look at the final question. In an experiment, an inflated balloon was placed in an air rocket. In the diagram below, air was released from the balloon, which caused the rocket to move upwards. The balloon was fully deflated at position 2, and the rocket stopped moving upwards at position 3. Give a reason why the air rocket continued to move upwards from position 2 to position 3. Elastic potential energy of the inflated balloon was converted to kinetic energy of the rocket as it deflated. When the balloon is fully deflated at position 2, it means that the balloon is no longer pushing the air rocket upwards. Its gravitational potential energy is still increasing. This means that some other form of energy has to be present that is being converted to gravitational potential energy. What caused the movement? Let's look at the answer. The rocket still possessed kinetic energy, which caused it to continue moving upwards. Let's look at part B of the question. An inflated balloon was released and it moved in different directions, as shown in the diagram below. Give a reason why the balloon did not move in a straight line, even though there was no wind acting on it. As air was being pushed out of the balloon, it created a forward thrust. Note that it is now moving in a random direction, unlike the air rocket. What disrupts the balloon from moving in a single direction? Let's look at the answer. Air was released from the balloon in different directions. The change in direction of air being pushed out moved the balloon in different directions.